Hi, I'm Jack Utzman with Turck, and today I'm just going to talk about the Q180 and Q300 that were recently added to our portfolio. So these are both Ethernet-based readers. The major difference between the two is you can see the size. They both have 4 external antenna connections that you would connect over coax for DXP, power, Ethernet. They both can be powered with Ethernet Plus as well. But the Q180 doesn't have an internal antenna, and the Q300 does have an internal antenna. So it has the 4 external and then an internal antenna. So you can do more reading. But the point of the video today is to talk about, we kind of have some parameterization and testing tools built into a web interface that you can get from our website. So I'll show that. First, I'll go online with the device. And then while I'm doing that, here I have, you can see these 2 boxes. This tag just has AAA as the EPC, and this box is B. So I'm kind of putting box A a little closer than box B. So going into the application, this RFID test, this kind of just runs what you have parameterized in the device. Right now, I think the signal strength is just 15 dB, which is half power. You can go from 1 to 30. So I'll just trigger a read here. And so B is green and A is this red. And you can see box A has a signal strength from -45 to -40, and B is -47 to -50. So you can see there's kind of a clear difference. A is obviously closer than B. So you can kind of see that in the signal. But beyond that, if you're trying to set this up, I only want to read box A, and box B, I don't want to read. Maybe this is on a conveyor going one way, this is on a different conveyor going somewhere else, and you just care about what's here. Sure, in the real world, they probably wouldn't be this close, but this tag population tool is used to kind of determine that power level. So I'll just do a sweep from, again, because they're very close. In a usual UHF application, you could go up to like 10 meters away, depending on the environment and tag you have. But because this is very close, I'm going to start the power at 3 dBm, a really low end, and only go up to maybe 12, because I won't need a lot of power to read these boxes. And I'm going to enable the right hand and left hand antenna in here. So kind of what right hand and left hand polarized means is right hand, it's going to come out in a corkscrew going right hand clockwise. Left hand would be the opposite direction. And the reason that can be useful is in high metal environments, based off of the spin of that, it's going to bounce and deflect off of metal in different directions. So if you're actually switching between left and right hand, you'll be able to cover that area more completely than if you just had right hand or if you just had left hand. But I'll start this power sweep here. So kind of what it's doing, it's going through and it's going to read right and then left, and we're seeing how many tags we read. So right now we're at 6 dBm. We're still just seeing tag A, and then 8 dBm, still seeing tag A. And now here at 9, it looks like this is the point. At 8 and 9 is when we start seeing tag A and tag B. So we'll let this run all the way to 12. So now the sweep is done, and you can kind of see pretty clearly. At dBm 8, I start seeing B. At 7 and below, I'm just seeing A. So maybe if I'm actually looking at this in the parameters, I'm going to go, all right, 6 is our starting point. And of course, you do more testing in your real world, but this is just like a really good starting point of, okay, maybe 7 on a stray read, you could read this box, but for now, I just say 6, and that's where we'd start. So if you're kind of thinking of filtering, power level is that first filter you're going to want, and after that, it's going to be signal strength. So this tag trace is a good way to help you do that signal strength. So if I start here, again, this is just, if you see here, this is that RSSI value. again, the closer to 0, the stronger. So I can see A is -42 to -40, and B is -50 to -47, 48. So really here I could also say, in your software, any tag with a signal strength weaker than -45, that's a stray read. That's something I don't care about. And sure, maybe box A could dip below -45. Maybe it's unaligned, maybe it fell over on a conveyor. But you would hope that, if it's unaligned, maybe at this point it's -45, but at this point, it's -44. And you'd read this, but you wouldn't read this. So that's kind of what you do in the tag trace. And then you kind of use that knowledge you gain from these use cases, and then you go into the parameters, and then you set your parameters. So first, when you're doing this, you go into this antenna setup. So if you think back to that power trace, I was using the right and left hand antenna. So I'm going to say, how many antennas am I using? 2. Enter that. And now it autofilled to the right and left hand, but you can kind of see here, you could select, right or left, and then the horizontal and vertical are all the internal ones. And then here we have these 4 external ones where you could connect a passive antenna. But for this, I'm just doing right and left. And then we go to here is where we can change that power level. So I think we said 6 was a good power level. So I'm going to change that to 6. And then in this case, usually you'll mainly be changing power, but this is also good to verify that it's enabled. Switch to next antenna if no transponder was read. That just means if on the right hand polarized antenna, I don't see any tag, it means I'm not going to wait on the right hand one until I see a tag. It means I'm going to execute a read on the right. Oh, I don't see anything. I'm going to switch to the left, and same with the left here. If I disable it, it'd mean we'd read on the right and we'd hop to the left, and then we'd wait on the left until we see a tag before we hop back. But we want both of those enabled, so they're hopping between the antennas. So I'm going to write that information in the parameter. So then when we go back to the application, we shouldn't see B and we should see A, because I changed that power on this antenna down to 6. So if I trigger a read here, now we're only seeing one tag, and that tag is A. So that kind of worked as we wanted. And you can kind of see with the power level lower, it's kind of jumping around. It's a little less consistent here, but we're still only seeing box A and not box B. So now, if I kind of move these boxes out of the way and turn the power level back up, I'll show kind of one of the last test cases. So in this box, I have 11 t-shirts, and each shirt has a tag on it. Clothing is a good thing to read through with RFID. In general, things like metal and water can be difficult. Metal can reflect or will reflect the waves. So if this box was metal, or if I had 12 metal items in here and one's in the center, sure, I might be able to read the outside ones, but I'm not going to read the ones in the middle because it'll be blocked. But something like clothing, I just have 11 shirts jumbled up in here, mixed up. It kind of doesn't matter because the wave will read through all of that, and we should read all 11 tags. I'm just going to turn the power up from 6 here because 6 is kind of low. So maybe I'll change it to something like 20, just so I'm comfortable. I'll get all those reads. So I'll write this stronger signal here. Sometimes if you just change the power, it doesn't want to allow you to write. So I'll just toggle one variable at that point. So I can get that right in. So now, if we go to this gate use case, I already have these 11 tags in. If you didn't, you would just, draw a gate. I'm saying it's going to be 4 columns, 3 rows, because I know I have 11 items. So there, then you fill the gate with EPCs. So I filled my gate. The reason why you're seeing 12 is CCC. There's another box beyond here that's out of shot, but that's that CCC. But in here, there's these other 11. So then I'll take this away, and it'd be kind of, imagine this is on a conveyor. You'd teach it. These are the 11 tags I'm looking for, and then you take it off, and then you'd run that conveyor at speed with this box on. And as it came through, like right here, it's off. So I'll start that inventory. I guess it's reading some of them because I'm not holding it far enough. It can still read it, and it's still seeing that C. But as I put it in front of it, now it read all of them. So you can visually see they turn green. I'll stop this read. This number next to them, that's the count, how often it was read. So all of them were read pretty well. Say maybe I had my power at 15 and I wouldn't read them. Then you could say, okay, maybe I need a higher power, or maybe, if the asset you're tracking does have liquid or does have metal, or there's other environmental things that could be causing you not to get reads, this can be a good indicator of, okay, I'm not seeing my reads. You can do this really quickly and get an idea of, is this going to work, or am I going to have troubles here, before you invest the time in, programming your PLC or making a code assist program. So this is just a really easy, almost proof of concept that you can do. But that is really what I was here to show you today. So that's the Q180 and Q300. And that's kind of just how you can take an application you have, test it in this software pretty simply, change the parameters in the device. And that would be, if you made a PLC program, you can write these parameters in here and they'll stick. So you don't have to do that parameterization in the PLC as well. I hope this was helpful for you. Jack Utzman, have a good day.